Good morning. This following presentation has a kind of personal beginning. Did you ever declare bankruptcy? Actually, I'm not talking about money. I'm more talking on a higher level, on an academic level about ideas. Let me start at the beginning to give you a chance to understand the story. So I work for the cloud. My name is Frank Munz. I work for Amazon Web Services as a technical evangelist, and well, that's me. And I don't know when you started to look into machine learning, into AI. When I studied, we wanted to do some machine learning, so I took my best friend at that time from the university. We went to a bookshop, bought a C++ book, and 10 minutes later, we started coding this CMAC that you see here on the slide. So the first C stands basically for brain, and the second C stands for computer. And looking back at this now, it's a little bit like what you know from MXNet or TensorFlow. But that time, that wasn't sure. It does the same thing. It does like image, not really image, but object recognition. And our plan was to teach it to be able to detect circles and triangles. And the result was okay-ish. Basically, it could distinguish circles and triangles. But then if you rotate the triangle a little bit, it would just not work anymore. And then something surprisingly happened. Like our computer science teacher, he resigned. He gave up. I don't think it was because of what we handed in, our programming, but this guy basically top-notch in his field. He said, look, everything that is being published now was published before, or it's kind of rubbish. It's just not useful. And he went and took a consulting job, and this is like when the AI winter started. Again, I don't think it's because of our program, but there was a long period when everything was frozen and covered under snow, and there was nothing happening for many, many years. And if you think about this declaration of bankruptcy, and if you Wikipedia it today, it's called AI winter, it's a very charming thing, for a research area. They didn't keep talking. They just said no, let's be quiet. There's nothing happening. And then AI and machine learning came back. It came back with the stuff like this. This is one of the most popular online courses that you could take today. I took it, and it reminded me of my university lectures where my best friend said, look, Frank, we struggle to write those symbols. How will we ever be good at this now? And this is also the reason why today a lot of people say, isn't this machine learning thing the same thing as statistics? No, isn't it just statistics at the end? And I tend to say, well, it's like medicine and chemistry. I'm a tech guy, If I go to a doctor and he understands about chemistry, I feel more confident now. But then if I break my leg, if I have a heart attack, if I have a melanoma, would I go to somebody who studied about oxygen and hydrogen? No, it's a different level of abstraction. And that's another thing about computer science and being good at computer science is working with the right level of abstraction at the right point of time. So if you're looking into AI and machine learning, my opinion is don't do this. That's a great course. It's a brilliant colleague. But in my opinion, you shouldn't start implementing this stuff yourself like what we did in C++ like many, many years ago. What we do these days in machine learning is, clustering. We want to find out. We want to learn. We don't want to learn from images. We want to cluster handwritten digits. And the thing is, if you don't start coding yourself, what should you do? What we give you is these notebooks, Jupyter and Zeppelin notebooks, and we have a service, it's called Amazon SageMaker. This is where you get this notebook. And if you've never seen one, it looks like a wiki page, like your internal wiki that explains how you have to do your expenses at the end of the month. And this wiki page, it has pre-formatted text that explains you what is happening, and then it has these blocks of code that you can execute with shift return. So it's beautifully. It's just running, and you can use them, and we give you dozens of examples, and if you look up the internet in GitHub, you find hundreds of them. And if you start with this, you don't start implementing the algorithm because we have those algorithms pre-installed, pre-configured, and you just say, I want to use MXNet, TensorFlow, scikit-learning, whatever. And that's the much easier, the much better approach. And then if you train such a model, we spin up the hardware for you in the cloud. You define how many instances you want, and we shut it down once the training is done, and you just pay for exactly the amount of time that the model was running. So that's a good start. And then we have another class of models and questions that we understand really well. And one of this is like supervised learning, where we feed the computer with thousands of images of cats and dogs and cats and dogs, and then at the end, after feeding him like 60,000 images, we say, can you tell me now if this picture is a cat or a dog? No. This is what a lot of examples in machine learning look these days. And it sounds like a stupid example, and you think like, couldn't any 4- or 6-year-old child do the same better? How about this? Can you tell dog or non-dog? Not that easy. How long would a 4-year-old child be interested in playing this game? How about this one? Cleaning equipment or dog, or maybe both? We don't know. It's not that easy sometimes. What I'm trying to say, this kind of example we understand really well. That's the kind of entry-level things that we show to people, and that's what they use those notebooks for, and they play with it, and this is how they learn. Now, this is how we democratize machine learning. This is another example. When you use a notebook, you should be able to read and change existing Python code. That's a very comfortable level, entry level for a developer. You don't start implementing TensorFlow yourself, you change existing Python code. This is an example that I took in our old office. It's a picture I took in like 3 seconds, and then using this service, it's called recognition, machine learning gets as difficult as uploading a picture to Facebook. And that's what I did. Well, I didn't upload it to Facebook, but to SageMaker. And then SageMaker says, look, this is a scene that contains a bike. It contains a human. It contains, and that's what I like a lot, it says like with a 70-something% probability, it's about interior design. Well, it's just our office, but this bike is there to look nice and not for people to drive home. So that's the interesting thing when this algorithm starts telling you this is interior design all of a sudden. And that's just something I did casually. It's a colleague of mine from marketing on this picture. And this way, it's a service, you send it a picture, there's a web console, and you get the result back. If you're a programmer, you get an API. You give us a JSON structure, and we send you back the results, what we detect in this picture, and what's the likelihood of this being a real bike and being a real human and being interior design, which is less than for the probability of bike and human. Now, this is what we offer. But this is, at the end, it's just ideas. And the question is, do people really use that? And the answer is yes. We have like tens of thousands of customers using this SageMaker service and using the other machine learning services. We had the healthcare example in the previous talk. We have GE Healthcare using machine learning on AWS. We have hotels.com. A lot of those hotel pictures that you see in the portals, when they say, look, this is your destination. Do you want to see pool pictures? Do you want to see pictures from the bedroom, from the restaurant, from the beach? Guess how they are sorted, categorized. They use exactly the same mechanism. No? There is an API that says that's a pool picture, that's a bedroom picture, that's a restaurant picture. This is how it works these days. So there's nobody really sorting these pictures. And now, what I'm trying to say is, this is the service that we offer to you, but the question is, who's picking it up? And I gave you some examples. One that I particularly like is a customer that was on the keynote stage at our summit in Amsterdam, talking to like 3,000 people, just like you, live. And he was explaining how they built a mobile application to detect skin cancers. So basically, it's an app that you install on your mobile, and it says 1 out of 5 people in their life, they catch skin cancer. And there's different types of skin cancers. Some are super dangerous, some are not. But there's also a lot of people that don't have access to, just going to a dermatologist the next week. And some of them, if you have them, you should detect them very quickly. So skin vision they built this app that you see in the background, and they detected over 27,000 skin cancers yet, and I think it was like 5,000 melanomas. And the melanoma is the small thing. This is when your dermatologist has a very serious face and says, look, there is something, we need to do something very quickly because they don't want it to spread. And they had like 5,000 of them detected using machine learning in the AWS cloud. I don't want to go into the details because obviously they don't publish all the details, but they use our services. And what they do is they extract the features from such an image that you take with your smartphone and then say, you know, is it dangerous or is it not dangerous? And that helps a lot of people. And it's available now. You can download it and use it. Now, again, this is something that is kind of established. This is working. You know, this is state of the art. So people use machine learning services in the cloud, and a lot of companies come up with new ideas, with new projects. There is an area that used to be very, very exclusive up to only a few years ago, and it's called reinforcement learning. Now, reinforcement learning is not, you know, about giving thousands of pictures to a computer and telling it, look, this is a dog, that's a cat, that's a dog, a cat. It doesn't work like this. If you have a problem like this, imagine this is your car. How many PS, how many horsepower does your car have? Imagine it's not strong enough to get to the right-hand side. What do you do? Well, the thing is, you go backward and forward. It's like you don't need to explain this to a small child on a swing. They automatically know how to swing. And yeah, you go backward and forward, and you try to get the momentum and get up to the hill. Now, if you try to teach this to a computer, you have no label, because you know there is no label. But you have a cost function, and this cost function says, the higher you get, the better you do. And now go and play with yourself and figure out what is best. And that's like in one sentence, that's reinforcement learning. And this was something that like very few people in academics were doing, and like a very few companies could really offer this to you as, you know, as consulting or as a service. And that's something that caught our eye, because this kind of solution helps you to solve a lot of problems. With the same algorithm, you can kind of play and win against 30 different Atari games. And you can also use it, you know, to build self-driving cars. And our thinking was like, how do we get something that is very, very special, you know, very academic, in the hands of very few people, and make, you know, everyone use it? How do you make people use something very complicated? Because usually they don't want to put the effort in. So what we did is we built a car. We built a self-driving car, which is a small 1 to 18 size self-driving car. So it's not a real car, it's a model car. And this model car, you can train it by reinforcement learning. The surprising thing is that the car itself in this self-driving car is the least important part. Because remember, there's this cost function that basically tells if the car is driving well or not so well. If it stays on track, it's driving well, and you see it here. That was my first attempt of, you know, you program this cost function yourself, you let the car drive in a simulator. That's why I say the car itself is the least important part. And once it learned to drive in the simulator, you transplant the knowledge on the car. Sounds good now. Basically what you do is you take this machine learning model and you upload it to the car. And then this car is driving on a real track, and this real track, we build it for you. So we have those AWS summits, like in most of the big cities in Europe, and this is where we do a competition. This is where you can come with your own model, with your own cost function, and you can download it onto the car, and you can see what's your lap time. No, my lap time was, this is recording, I'm not even saying it. So my lap time was below 1 minute, which is like not really good. And the experts, they have like less than 10 seconds. I think they're around 7 seconds for one lap time. And people love this, you know, they want to compete. That's the dopamine in your brain that wants you, let's try again, let's try and see if I can be, you know, better than Frank, less than half a minute, less than 10 seconds. That's this gaming effect. That's why children, we always say, well, they don't concentrate for their homework, but they concentrate on their PlayStation for 6 hours. That's the same effect. No, people love this. So we use this gamification a lot, also in other contexts. But we used it here for the reinforcement learning, and people love to compete. And finally, once we have the winner per country, what we want to do is we want to have a final championship in Las Vegas. This is where we have the big conference once per year and put those people together and let them compete against each other. But you know, the side effect, the byproduct is that thousands of developers are doing reinforcement learning, which was in the hands of very few academics or small companies just a few years ago. Now, with this, I want to show you one last example. So I think you've seen that we have those services and we think they're ready for every developer to be used. You've seen that we have many customers and we have those customers that really use machine learning in medicine, and they use the cloud in medicine for something that is like not an easy topic. And we also use it internally. You know the saying about, do companies eat their own dog food? We do it. We actually love to use our own machine learning services. And the thing that we built, maybe you've seen it already on YouTube, but it's the delivery robot from Amazon.com. Okay, with this I want to say thank you for your attention. I'll be around if you have questions. I'll be at the Intel booth for a while. Just come and talk to me, please. Thank you.